Troubleshooting an arc fault breaker trip in new construction requires a systematic approach. Firstly, check for physical damage. Carefully inspect all visible wiring for any signs of cuts, abrasions, or insulation breaches. Pay close attention to areas where wires may have been stapled or run through tight spaces. Examine all light fixtures connected to the circuit, looking for loose connections, cracked or damaged components, or any other signs of physical stress. Secondly, determine the circuit path. Trace the entire circuit from the breaker panel to each outlet, switch, and light fixture connected to it. A detailed circuit map can be very helpful in this process. Use a continuity tester or a wire tracer to positively verify the circuit path, ensuring that all connections are as they should be and that there are no unintended branches or interruptions in the circuit. Thirdly, test devices. Disconnect all fixtures and outlets from the circuit. This isolates each device, allowing for individual testing. Use a multimeter to test each disconnected device for proper grounding and insulation resistance. Look for any signs of shorts to ground or low insulation resistance which could indicate a fault within the device. Replace any defective devices immediately. Fourthly, inspect electrical boxes. Carefully check all electrical boxes along the circuit path for any loose screws, sharp edges, or nails that could be puncturing or damaging the wiring. Inspect all ground wires within the boxes, ensuring that they are properly connected to both the metal box itself and to each device within the box. A secure and reliable ground connection is essential for preventing arc faults. Fifthly, look for overcrowding. Too many wires crammed into an electrical box can cause heat buildup and create conditions that increase the risk of arcing. If you find any overcrowded boxes, consider installing additional junction boxes to spread out the wiring and provide more space for connections. Always ensure that electrical boxes are sized appropriately for the number and gauge of wires they contain, following all applicable electrical codes. Sixthly, examine splices. Inspect all wire splices within the circuit, ensuring that they are properly made using wire nuts or other approved methods. Look for any signs of burnt or discolored wires or splices, which could indicate arcing or overheating. Loose or poorly made splices are a common cause of arc fault breaker trips. Seventhly, address environmental factors. Check for any signs of moisture or dust in electrical boxes or fixtures, as these contaminants can create conductive paths and contribute to arc faults. Extreme temperatures or humidity can also trigger arc fault trips in some cases. Improve ventilation in areas prone to high humidity or consider using moisture-proof enclosures for electrical components where necessary. Eighthly, diagnose with a circuit breaker analyzer. If all of the above steps have been taken and the issue still remains unresolved, consider using a specialized circuit breaker analyzer to pinpoint the exact location of the arcing. This device is designed to detect high-frequency arcing and can provide detailed information on its severity and location within the circuit. A circuit breaker analyzer can be a valuable tool for identifying intermittent or hard-to-find arc faults. An arc fault circuit interrupter, or FSI breaker, is designed to protect against fires caused by electrical arcs. These arcs can occur due to damaged or deteriorated wiring, loose connections, or other faults in the electrical system. When an FSI breaker detects an arc, it quickly trips the circuit, cutting off the flow of electricity and preventing a fire from starting. FSI breakers are required in many areas for new construction and renovations, particularly in bedrooms and other living areas. It is important to understand how FSI breakers work and how to troubleshoot them effectively. An arc fault is an unintended electrical discharge between two or more conductors. These arcs can generate intense heat, which can ignite nearby flammable materials and cause a fire. Common causes of arc faults include damaged insulation, loose connections, and faulty electrical components. FSI breakers are designed to detect the unique characteristics of arc faults, such as high-frequency noise and irregular current patterns. When an FSI breaker detects an arc, it trips the circuit much faster than a standard circuit breaker, reducing the risk of fire. There are two main types of FSI breakers: branch or combination FSI breakers and outlet FSI breakers. Branch or combination of SI breakers are installed in the electrical panel and protect the entire circuit, including the wiring, outlets, and fixtures. Outlet SI breakers are installed at the first outlet on the circuit and protect the wiring downstream from that outlet. When troubleshooting an arc fault breaker trip, it is important to follow a systematic approach. Firstly, gather information about the problem. Ask the homeowner or building occupant about the circumstances surrounding the trip. When did the trip occur? What devices were in use at the time? Were there any unusual events, such as a power surge or a lightning strike? This information can help you narrow down the possible causes of the trip. Secondly, inspect the circuit visually. Look for any obvious signs of damage or defects, such as frayed wires, loose connections, or cracked outlets. Pay close attention to areas where the wiring may be exposed to physical stress, such as where it passes through walls or floors. Thirdly, test the circuit with a multimeter. Use a multimeter to measure the voltage, current, and resistance of the circuit. This can help you identify any shorts, opens, or ground faults. Be sure to test the circuit under different load conditions, as some faults may only appear when the circuit is under load. Fourthly, use an FSI tester. An FSI tester is a specialized tool that can simulate arc faults and verify that the FSI breaker is functioning properly. This can help you determine whether the problem is with the breaker itself or with the wiring in the circuit. Fifthly, isolate the problem. If you suspect that a particular device or appliance is causing the trip, disconnect it from the circuit and see if the problem goes away. If so, then the device is likely the source of the arc fault. Sixthly, repair or replace faulty components. Once you have identified the source of the arc fault, repair or replace the faulty components. This may involve replacing damaged wiring, tightening loose connections, or replacing defective outlets or fixtures. When working with electrical wiring, always follow safe work practices. Turn off the power to the circuit before beginning any work. Use insulated tools and wear appropriate personal protective equipment. If you are not comfortable working with electricity, call a qualified electrician. Here are some common causes of arc fault breaker trips. Loose connections. Loose connections can create resistance in the circuit, which can generate heat and cause an arc fault. Check all wire connections, including those at outlets, switches, and light fixtures. Tighten any loose connections and replace any damaged connectors. Damaged wiring. Damaged wiring can expose the conductors and create a path for an arc fault. Inspect all wiring for signs of damage, such as frayed insulation, cuts, or abrasions. Replace any damaged wiring. Overloaded circuits. Overloading a circuit can cause the wiring to overheat and create an arc fault. Check the amp rating of the circuit and make sure that it is not being exceeded. Reduce the load on the circuit by disconnecting some of the devices or appliances that are plugged into it. Faulty appliances. Faulty appliances can draw excessive current or have internal faults that can cause an arc fault. Test all appliances that are plugged into the circuit and replace any that are faulty. Moisture can create a conductive path between conductors, which can cause an arc fault. Keep electrical wiring and components dry and free from moisture. If you suspect that moisture is causing the arc fault, dry out the affected area and seal it off from further moisture intrusion. Rodent damage. Rodents can chew on electrical wiring, damaging the insulation and creating a path for an arc fault. Inspect all wiring for signs of rodent damage and repair or replace any damaged wiring. If you have a rodent problem, take steps to eliminate the rodents and prevent them from returning. Dust and debris. Dust and debris can accumulate on electrical components and create a conductive path, which can cause an arc fault. Clean electrical components regularly to remove dust and debris. Use a vacuum cleaner or a soft brush to clean the components. Avoid using water or other liquids to clean electrical components, as this can create a shock hazard. Improper wiring practices. Improper wiring practices can create conditions that increase the risk of arc faults. Follow all applicable electrical codes and standards when installing or repairing electrical wiring. Use the correct size and type of wire for the application. Make sure that all connections are tight and secure. Protect wiring from physical damage. By following these tips, you can troubleshoot arc fault breaker trips effectively and ensure the safety of your electrical system. When dealing with electrical systems, always prioritize safety. If you are unsure about any aspect of the troubleshooting process, consult a qualified electrician. Regular maintenance and inspection of your electrical system can help prevent arc faults and other electrical problems. Check your electrical wiring and components regularly for signs of damage or wear. Replace any faulty components promptly. Keep your electrical system clean and dry. By taking these steps, you can help ensure the safety and reliability of your electrical system. Electrical safety is paramount. Before undertaking any electrical work, ensure that you have a solid understanding of electrical safety principles and practices. Always disconnect the power supply before working on any electrical circuit or component. Use appropriate personal protective equipment such as insulated gloves and safety glasses. Work in a well-lit and dry environment. If you are not comfortable working with electricity, call a qualified electrician. The NEC, or National Electrical Code, provides comprehensive guidelines for electrical installations and safety. Familiarize yourself with the relevant sections of the NEC, particularly those related to arc fault circuit interrupters. The NEC specifies where SI protection is required and provides guidance on the installation and testing of SI breakers. Staying up to date with the latest version of the NEC is essential for ensuring electrical safety and compliance. Many arc fault problems are caused by improper grounding. The ground wire provides a safe path for electricity to flow in the event of a fault, preventing dangerous voltage buildup and reducing the risk of electric shock. Ensure that all ground wires are properly connected to the grounding electrode system, which typically consists of a grounding rod or a connection to the metal water pipe. Test the ground connections with a multimeter to verify that they are providing a low resistance path to ground. Incorrect wire gauge can also contribute to arc fault problems. Using wire that is too small for the circuit's current carrying capacity can cause the wire to overheat and damage the insulation, increasing the risk of arc faults. Consult the NEC or a qualified electrician to determine the correct wire gauge for each circuit. Ensure that all wiring is properly sized and that connections are made with appropriately sized connectors. Electrical panels can sometimes become overcrowded, making it difficult to work on the wiring and increasing the risk of accidental shorts or ground faults. If your electrical panel is overcrowded, consider installing a subpanel to provide additional space for circuits. A subpanel is a smaller electrical panel that is fed from the main panel. It can be used to isolate certain circuits or to provide additional capacity for future expansion. Surge protection devices, or SPDs, can help protect your electrical system from damage caused by voltage surges. Voltage surges can be caused by lightning strikes, power outages, or other electrical disturbances. SPD divert excess voltage away from sensitive electronic equipment, preventing damage and reducing the risk of arc faults. Consider installing SPD at the main electrical panel and at individual outlets to provide comprehensive surge protection. When troubleshooting arc fault breaker trips, it is important to document your findings carefully. Keep a detailed record of the steps you have taken, the tests you have performed, and the results you have obtained. This documentation can be helpful in identifying patterns or trends that may lead to the source of the problem. It can also be useful if you need to consult with a qualified electrician. Consider using a circuit breaker analyzer tool. These tools inject a signal into the wire and can trace where the arcing is. By using this tool, it can save you time and effort on trying to find the source.